Okay. So here are my office hours: 9:30 to 11:15 Tuesday, 12:30 to 2:15 Thursday. I've designed those hours so that everyone can get at least 1 hour with me, as long as you don't have 3 classes back to back in the middle of the day, Tuesday, Thursday. So if you have 3, the only people who can claim that they aren't available during my office hours are if you have 3 classes back to back Tuesday, Thursday. So there'll only be a few of you. Okay, but everyone else, you should be able to get at least an hour in there. And then there's Roy. Do you have your office hours yet? Nope. As soon as the office hours gets his finalized, I'll put those on Blackboard. I'll show you that in a second. So, Pathways Workbook. So, essential element, I've just been told that another shipment will be at the ASU bookstore within 24 hours. So, like tomorrow morning, it should be there. Okay? And possibly the other bookstores too. There's one at College and University across from Panda Express. And there's one near McDonald's on Rural and Lemon. Okay? But for sure, in the next 24 hours, there should be new ones coming in. So you just have to get your feet over there and check if you have it. How many people do not have the workbook? Oh, okay, so less than a quarter of you. Good. So just keep trying at the ASU bookstore. Another shipment coming soon. Okay? Graphing calculator. If you have bought a graphing calculator and never used it before, there's a workshop for you. It's kind of a beginner workshop getting started. If you've used it for a course, it's probably not going to be too beneficial for you. Okay, so I'll leave those up here on the table in case you want to go to the graphing calculator workshop. Locations and dates are there. So there's lots of little elements to this course, and several we haven't talked about yet, so I'm going to inform you about them little by little, rather than overwhelming you all at once. So we've talked about Blackboard. Rational reasoning, that's the website that you'll get the online access to. Haven't talked about that yet. We'll put that off a little longer. Web work, you should have logged in and started. Okay? So the Blackboard and web work are what we've got so far. TopNet is an in-class questioning system, like for clickers. You're going to use your own devices. Okay, so through the internet. But we'll hold off again and do that later. So attendance, you're allowed 6 absences from lecture or 2 absences from recitation. If you exceed either of those, you receive an EN for the course. You gotta come, okay? And so what happens as the semester goes on, I begin to see fewer and fewer of you, okay? And that can't happen. You gotta come to class. The discussions that we have are critical for the development of the ideas, okay? Homework. So in addition to the web work, I'm going to talk about written homework today. We'll talk about that when we go to Blackboard. There's a tutoring help room. I'm going to keep reminding you about this almost every lecture, because there may be opportunities for you to get help on campus, but this will be by far the best for you, because we're doing our best to train the tutors there in this curriculum, which is very unique because it's so conceptual, right? And so other tutors in other arenas may open this book and be like, what the heck is this? I've never seen this stuff before, and may have trouble helping you. We're trying to train these tutors the best we can. And so there's pretty good hours. Monday, Wednesday, Friday, 7:30 to 1:15, Tuesday, Thursday, 9 to 6. Okay, this is free. Okay, this is going to be besides me and Roy, this is going to be your best resource for help. Okay, I will continue to remind you about that.
One other thing is the
Please.
office hours that we'll have will be held in that period.
Yeah, me too. So some of my office hours will be in there. Now, my office is right across the hall from this. So ECA is the building right across from the bookstore. So if you cross the street from the bookstore, go up to the 2nd floor. You're on ECA, 2nd floor. That's where my office is. That's where this help lab is.
Can we just go there, or do we have to make like a reservation?
No, you just show up. And you can even just show up and do your homework there and never ask a question. Totally fine. Or you can have a list of questions and wait for your turn to get help. So some students like to just go and work, and then inevitably questions come up, and then you've got help right there. Okay? So, and we'll have some of our office hours in that room. Roy, is it all of yours? Yeah. All of Roy's will be in that room. Okay, so this week, as far as testing, you're taking the PCA, the Pre-Calculus Assessment Pretest. Okay, that is in PSA 21. Enter between 10:30 and 6:30. That's the basement of PSA. So you've got lots of time here to do this, Tuesday, Wednesday, or Thursday. Just carve out an hour for everything, getting there, signing in, taking the test, and leaving. But the actual taking the test, for most of you, will be less than an hour. It is required. Everyone has to take this, and do your best. I'll give you, depending on your performance, I'll give you some bonus on exam 1. Don't forget the pretest. Okay, so grade calculation, pretty standard. The homework's 25%, the in-class stuff 15%, exams 40, final 20. The rest is general stuff. Last day for open drop ads this Wednesday, and then we got withdrawal deadlines and administrative details. Any questions on the syllabus? Okay, let's go to Blackboard, and I'm going to point out a few things on Blackboard.
Where's the pretest sheet?
PSA 21, basement of PSA. PSA 21, it's right there on the syllabus, if you forget. It's also on the Blackboard announcements, which we'll go to right now. Okay, so, so the pretest info is right there on Blackboard announcements as well. So syllabus, you should have found that and downloaded it. Course websites, we'll skip that for now. Office hours, there are my office hours. And then we'll put up Roy's here as well when we know for sure. Written homework, new element. So the way written homework is going to work is here. Written homework is due in your recitation section during the week specified. So you guys have Wednesdays and Fridays, is that right? Some of you are Wednesday, some of you are Friday. So next week, those who are on Wednesday, you're going to hand it in recitation on the 4th, and those who have Friday recitation will hand it in on the 6th. Okay? Now, where are these problems? These are the homework problems in the back of the module. So that each module consists of investigations. That's what you'll be doing in class. And at the end of each module is the homework. Okay? There's no room for homework. You do that on separate sheets of paper. Okay, so this assignment starts, let's see, number 6. Page 53. Page 53 is where it starts. So make sure, just look up in the upper right-hand corner. It says homework, not investigations. So this is not the investigations, this is homework. So what did I say, page 53? We'll just do it right now. Okay, so there we go. No question, no ambiguity here. Mod 2 homework starting on page 53. You're going to do these questions. I made a couple changes to the wording. Number 30 and 40, you can read that. But notice up here that you're going to be graded on professionalism, neatness, organization, readability. So you're handing in a professional set of work, and then accuracy. But most of the accuracy points will be for written explanations. I've purposefully picked ones where they're asking you to explain your reasoning. That's what this course is all about. Not just being able to find answers, but know what's going on, know the process, and understand what's going on in the background. So you're going to have to write out in complete sentences explanations, and that's what most of the accuracy points will be on those written explanations. Okay? Some of you are going to have a rude awakening when you get your first graded homework back because you just kind of scribbled some words down, some phrases. You're going to get no points for that, okay? You need good written explanations. Questions on how, so web work is going to be continually due. So we got the next web work is due Friday before class. You got 2 open sets right now of web work. One's due Wednesday before class. One's due Friday before class. And then you'll have homework, written homework due once a week. So now your web work, your main home page on web work looks like this. Here's Wednesday's homework due. And now we got a new set due Friday before class too. So just keep on top of the web work, and then homework, you'll have a week lead time to get the written homework, and you'll hand it in once a week in recitation. Questions about any of that? Okay, cool. Let's go. So just warm-up exercise. Introduce yourself to the person next to you. See if you can figure this out in 1 minute. Go. Yeah. No, I put the video up. The video class. Forgot to show you that. Can't seem to remember to show you guys this. All right, so okay, I forgot. My fault. So videos, class videos. So late in the day, like in the afternoon on day of class, if you go here to class videos, I will post the YouTube link so you can rewatch class. That is not by any means a reason to miss class. Okay, you got to be here for the live discussion. But so you may walk out of class feeling 90% confident you understood what's going on, but 4 hours later, 6 hours later, 12 hours later, it's very quickly fades when you have all these other things in your life, right? Other classes, social events, extracurricular activities, all these things are competing for your attention. New material that you understand in class is going to fade away. That's what this is for. If you can watch this within 24 hours of class, pause it, take formal notes, rethink through the ideas, that's going to be hugely helpful for you, okay? So take advantage of this, and I try to get those up late in the day, like late in the afternoon on the day of class, okay? I'll do my best, sometime a little bit later. But if you can watch it that night, find a way to watch it a little bit sped up so you can save time. You know, watch it at 1.5 speed, works great. Pause to think about things and take notes. Any questions about that?
Did they delete or?
Nope, I'll leave them all semester. I'll leave them up.
All right.
Fortunately, there's no way for me to. Okay, we'll try again here. Okay, we're back. Here we go. So, how'd we do? Where is Karen Lopez? Karen Lopez, how'd you do on meters? Quantity or not? Meters. Is that a quantity? According to our definition from Friday? Yeah. It is? Let's see. What do we think? Faisal. Where's Faisal? You agree with that? She says it's a quantity.
I agree.
All right. How about G?
Yes.
Is a quantity. Okay. 0 for 3. Meters is not a quantity. What is meters? Unit of measurement. What is a quantity again?
Measurable.
It's not a number. A measurable attribute of an object. A measurable attribute. How about the race car? How about Scott Moore? Is Scott here? How about Andrew? Where's Andrew? Race car. No, because it's an object. It's not a measurable attribute. What about width? Width is your first quantity in the list. It's a measurable attribute. Now, it's not well defined. We'll talk about it in a second. But it is a measurable attribute. The number 500. Wesley. Where's Wesley? You think it's a quantity or not? No, he's right. It's just a number. According to our definition of a quantity, which is a measurable attribute, it's a number. So about 7.6 seconds. Quantity or not? Still not. Still not an attribute. It's not. We want a measurable characteristic or attribute of an object. Acceleration. Yes. Okay. The 18,000 fans Is it a quantity or not? It's tricky. Oh, lots of no's. Why no?
You're talking about the 18,000 fans as a group. You're not measuring anything about that.
Right, right. So there's an implied measurement in it, but this is an object. It's the crowd. So we wanted to change that to be a quantity. How could we change that to be a quantity? What could you say? Yeah, someone said it. The number of fans. The number of fans, or the population in the stadium, or something like that. The number of fans. But this way it's worded here, it's an object. So don't forget, quantities are measurable attributes. Okay? But now we want to talk about well-defined. So width, acceleration, well-defined, not well-defined. So here's some examples of how to define those well. We could say that the width of the race car over its front axle. Well-defined? Very well-defined. Good. Okay. Acceleration of the race car during the last lap.
Yes.
Okay. And then we broke quantities up into two categories. What were the two categories? Changing and constant. What about the width of the race car over its front axle? Constant quantity. Acceleration of the race car during the last lap. Changing. Okay, it's changing. Okay, so I'm going to show you a video like several times. I'll keep running it. And so here's the idea. Distance is no longer a valid quantity because it's not well defined. In a given context, we can name lots of distances. We need to specify which one we're talking about. Same with time. Just to say time, it's not. It is a type of quantity, but you got to be specific. So I'm going to show you two runners running through a tunnel, and you're going to come up with, or the person next to you, come up with 6 different specific distance quantities. 3 changing and 3 constant, and same with 6 specific time quantities. See if you can do 3 constant and 3 changing. See how you do. So I'll just start showing the video. It's not quite as exciting as watching Usain Bolt, but good for our purposes. So we'll watch it once or twice. Your goal is 6 distance quantities, 3 that are constant, 3 that are changing, and then 6 time quantities, 3 constant and 3 changing. That's it. Okay, see if you can do it. So 6 distance quantities, 3 constant, 3 changing. 6 time quantities, 3 constant, 3 changing. Go. Work together. Okay. And then try to make your quantities related to objects in the video and not the video itself. Okay, so try not to reference the video. It's okay to, but as many as you can that are just specifically about the situation, like you were living it, not watching the video of it. Okay. Okay, where is Yahira? Okay. Did I say it right? Yahira. Okay, did you get, so don't tell us if it's changing or constant, but did you get one distance quantity out of this video? Specific.
Okay, so I'll say constant or changing, right?
Yeah, we'll guess after you say.
The distance between the camera and the runner.
Distance between the camera and the runner. Okay, so the first question we want to ask is it a quantity? Is it, now the second question is it specific enough? Is it specific enough? You got yes, you got this is kind of yes over here, kind of no over here. There's a really important detail we need here. You know what that is? Yeah, so tell me.
Female runner.
There you go. Now is it specific enough? If you don't specify that, you don't know. And that's different distances, right? Okay, so now, distance between the camera and the female runner. Is this a constant or changing quantity? Changing, excellent. Okay, so let's go on to Christopher Greco.
The distance of the funnel.
The distance of the tunnel. So if we, let's, can I say the distance from what?
Start to.
Distance from the start to the end of the tunnel. Is it a quantity?
Yes.
Is it specific enough?
Yes.
Is it constant or changing? You're all over it. How about Jackie Zong? Is Jackie here? I'm going to start learning your faces. You can't hide. Shruti. Shruti, can you give me another distance, but don't tell us what it is?
Use the distance from the start of the tunnel to the end of the tunnel.
That's what we just had for number 2. You got another one? No?
Yeah. Repeat it.
They're all repeats of the ones we've had before. Okay, where is Elizabeth Phillips? Elizabeth here? Elizabeth Phillips? Oh, did you get another distance one? Did you come up with anything? You're supposed to have 6, right? How do we do? Did we get 6? How about Lingzi Wu?
The distance between the male runner and the female runner.
Is it a quantity?
Yes.
Specific enough?
Yes.
Changing or constant? Yeah, good. Okay, how about going to just have someone volunteer? They think they got a good one to volunteer. Yes, sir.
Time from the
Let's,
like since the video starts, you want it to the video.
we're doing distances now, though. Distance.
Distance from the male runners to the start of the tunnel.
Distance from the male runner to the start of the tunnel. Specific?
Yes.
Quantity?
Yes.
Changing or constant? Oh, I heard some dissension there. The distance from the male runner to the start of the tunnel. Is that a changing or? Definitely changing, right? Changing. Okay, so back to you who had the time one. Let's all take your time one now. What was your time quantity that you wanted?
Oh yeah, like time the video starts to when it ends.
Time length of the video. Specific? Quantity? Constant or changing? It's a constant that the length of that video does not take on many values. It's one time length. It's one length of time. All right, how about Caitlin Humphreys?
The time of it took for the female runner to run through the tunnel.
Time for female runner to pass through tunnel. Is it specific?
Yes.
Yeah, sure, that's good. You should say from the start of the tunnel to the end of the tunnel, but I think this is pretty clear. Constant or changing? The time it took for her to pass through the tunnel. That is a constant quantity. It's the time from when she crossed, you start the clock, and then the only time here involved is when she crosses and leaves the tunnel. One time. Okay? Angelina. Angelica, I'm sorry. Angelica Morris.
I didn't give you.
Get into another. Tell me. Do you have it?
I have a question.
Sure.
About number 2. What if she loses energy? She wouldn't have.
If she what?
She loses her energy. She would need more time to cross the tunnel.
But for this specific context of those two entering the tunnel and leaving the tunnel, that's the frame. That's the framework. There was a one specific time it took her to get from there to there. It's not if she's going to go do it again. It's for her running through that tunnel that we watched. That was one particular amount of time. How can we just turn that one into a changing quantity? Who can change that into a changing quantity?
The word
Yes, ma'am.
Time elapsed since she passed the end of the tunnel.
Time elapsed since she exited?
Yeah.
Exited the tunnel. Okay. Is it specific enough? Constant or changing? Now it's changing because there's an amount of time. There's a little bit of time, a little bit more, a little bit more. There's different amounts of time that we could talk about that have gone by since she exited the tunnel. But the time elapsed to go through the tunnel is one time. Is it making sense? Let's do one more. Where's Austin Mathis?
Pretty much the keyword.
Austin, you got one more time for us?
The time for the female runner, for the time lapse for the female runner to see the time, or wait, time lapse for the female runner to get halfway through the tunnel
From when?
from the beginning.
From the start of the video? Okay, specific? Specific quantity? Constant or changing? Constants. Constant. There's a very specific one amount of time from when we start the video to when she gets halfway through the tunnel. Okay. Questions on these?
So like the keywords are like the lapse, and those are usually.
You could, no, don't. It's about an idea, not about looking for tricks, right? It's about an idea that you can have a time that starts but then is open-ended and can take on many values versus a time that is only is one particular amount of time. That's the way you want to think about it. So the wording, we can use elapsed to mean a constant time quantity. We can use that word elapsed. Yeah.
I just don't get how number 3 is changing and number 2 is constant.
Because it took her, I don't know, I'm going to guess. It took her 6.3 seconds to get through the tunnel. And every time you watch that video, it's going to be 6.3 seconds. But number 3, now, so if you start the clock, she leaves the tunnel. Now that time elapsed can take on many values. It can be like a half a second, it'd be 3 seconds, 4 seconds, 5 seconds since she left the tunnel. But maybe you're thinking the time elapsed since she exited the tunnel to the end of the video.
Yeah.
Well, that's a constant. But if you don't say to the end of the video, now you're leaving it open.
So we're not talking about the video specifically.
No. That's why I try to encourage you not to use the video. It's okay, but yeah. So this is just the time elapsed since she exited the tunnel. That takes on many values. Question back.
Yeah. How about the starting time between the female and the male?
The what?
Starting time.
Starting time?
Yeah.
I don't know what that means. Can you be more specific? Like entering the tunnel?
Yeah.
So the time between when the man enters the tunnel and when the woman enters the tunnel. Is that what you mean?
Yes.
Okay, is that a specific quantity?
Yes.
Would that be constant or changing? Constant. Because there was a certain amount of time. He entered a certain amount of time later, and there's only one time that it takes. So the time elapsed between when they entered is a constant quantity.
And how about when they start? Right.
When the video starts, they're already running. So
When the video starts.
when the video starts, what about it?
Is it quantity?
No. So the quantity is a measurable attribute. So now we're measuring time relative to the runners. So I don't know what you mean. Can you ask it? Yeah, I don't know. So when? Yeah, go ahead.
So for number 4, is it constant? Just
Yes,
like-
because when they start that video, there's only one amount of time that she gets to the halfway point of the bridge. Constant. Okay. All right, so what about changing quantities? So move to something new here. You've all seen this in past math and science courses. How do we represent changing quantities? Someone knows. How do we represent a changing quantity? Variables, right? That's what variables are for. We're representing a changing quantity. So for varying quantities, or same thing as changing quantities, we often assign a variable, a letter. So what's your favorite? X, right? X, Y, T, D, B, C, anything. To represent, what does that represent? It represents every value the quantity could take on, every numerical value. So now we're bringing numbers into it. That letter then means every single numerical quantity, numerical value that quantity could take on. Really important that's the way you view variables, okay? Variables vary. They vary. They take on many quantities. Okay, so now I want to talk about defining a variable well. It's very similar to defining a quantity well. So first of all, it's got to be a quantity, not the object itself. Okay, so L equals longboards. Is it a good definition? No, because longboards are what? Objects. Okay, so it's got to be a quantity. We worked hard at defining quantities. When you define a variable, you got to use a description of a quantity, not an object. Okay, it's got to be fully specific. We've worked hard on that. But then there's one more thing we need for a variable. What is it? We need units. So these are your three requirements to define a variable well. Quantity, not the object, fully specific, and include the units. So why now? So all this time we've been talking about quantities, we never said you needed a unit. But now when we talk about variables, we need a unit. Okay, so 30 seconds, talk to the person next to you. Why? Why is it that we want a unit for a variable, we don't need it for a quantity? Go. Okay, let me take a volunteer. Who thinks they're all over this? Why do we need a unit for variable but not necessarily quantity?
Because with variables, it's used in equations,
Okay.
and with equations, you can, based on what sign you use, it can get rid of a variable or add another variable, or like a unit. I should say not variable. Adders remove a unit.
I think that you're kind of you got the underlying idea, but so.
I would say that the reason why you really need a unit of measure is due to the fact that if you, depending on the unit of measure that you use, it could change the number that is associated with it. So if you're in centimeters compared to meters, it's two different numbers.
Right. So what's different about the variable from just the quantity itself? What's different? What are we introducing now?
It's more specific. You can use them in equations.
Okay. No, so what do they represent? Variables represent
Quantity.
values, numbers. Quantities are so you just use quantity as to mean number, to mean value. We mean quantity to mean a characteristic or an attribute, right? That we can measure. And so because the variable takes on values now, so what he was saying is correct. It's taking on values now. So are those values that it's taking on 8, 10, 15, 20? Are they centimeters, millimeters, meters? It matters, right? Because we've got to get the quantity right. Okay, so yes, now that we're bringing numbers into it, we have to know what those numbers are measured in. Okay, and that's what a variable is about, is all the values, all the numbers it could take on. So when we introduce those numbers, we need to know what those numbers mean. We need to know what those numbers mean. That's why there's units. Okay, but the quantity is just the physical thing of the distance, like from here to the wall, right? There's a distance there, right? Even if we don't measure it, right? And so it's just that amount of distance, and that's why we don't need a unit for that, because the quantity is talking about how far it is from here to there. But now when we measure it, we have a number, so we need a unit. Okay, so let's go back to that. Where is that? Where do we write all this down? There it is. Okay, so now we're going to find the changing quantities here, and let's set up some variables. So distance between the camera and the female runner. Changing or constant? Changing. We'll call it D. So are we done? Is it ready? Is it a well-defined variable?
No.
No. So we need in inches. Great. Okay, distance from the start to the end of the tunnel. Is it varying? No. So we could parameterize it with a letter, but we're going to stick to variables meaning changing quantities, okay? Distance between the male and female runner. Okay, changing, so we'll call it G for gender. Okay, the G equals distance between the male and female runner. In, he wants meters, great. Get the hang of it? So also now, we're going to pick the changing quantities. If we want to assign a variable, we need those units. Okay, so at the bookstore, each manager supervises 8 cashiers. The number of employees needed fluctuates throughout the semester. Okay, so I want you to define variables. And so let's define variables this way. M equals managers, C equals cashiers. Good? That's some nods.
No.
Oh, why? This is not good. What are these?
These are all
These are objects. These are objects. So what do we want? M is number of managers. And C is the number of cashiers. Okay? Don't define variables as objects. Don't define variables as objects. Be specific about what quantity you're defining. Okay? So write a formula that expresses the number of managers in terms of, this is language we want to make sure we've got down because it comes up a lot. We want to express the number of managers in terms of the number of cashiers. So that either means M equals something or it means C equals something. Which is it? M equals an expression with C's. Go for it. So M equals what expression of C's will give you the number of managers? Where's Nathaniel? Zoutra. You got this? M equals what? M equals 8C. What do you think? But it says manager supervises 8 cashiers, so M equals 8C, right?
C over 8. No, because your C is the total number of cashiers.
Okay.
So for every 8 cashiers, you need 1 manager, therefore it's C
So-
8.
Watch out for just writing equations, just looking at, right? So M equals 8C, right? That means you take the number of cashiers. If you multiply it by 8, you get the number of managers. Right? So M equals C over 8, or 1/8 C. Okay, so now what about the formula? We're all going to get this right now, 100%. Write this. Number of cashiers in terms of the number of managers. Go. Everyone gets this right. Where's Gabriella? Okay, you're representing us. Did you get it? So what's the whole equation? Tell me what the whole equation would be.
C equals M times
C equals M times
A.
8. Did you get it? Okay. We'll just assume you all got it too. Good job. All right. So now I want you to, while I take roll, I want you to go, we're going to start working in the investigations. If you don't have your book, you can look over someone's shoulder, or you can, I'll put it up on the screen. This is on page 24, I think. Go to 24, see if you can find this. Now this is bringing up something new. So we've talked about quantities and variables. So here it says, once we define a variable x to represent varying values of the quantity, we can write delta x to represent a change in x. A change in x. Okay? So are x and delta x the same quantity, or are they different quantities? Yeah, they're different, right? The change in a quantity, so the quantity of my height is, whatever, 76 inches or something like this. Okay? But the change in my height from now and the next year, right, is not, it's different. It's a different type of quantity, right? It's like negative half an inch or something like that, right? Hopefully not, but okay. Just keep sitting up straight. All right, and so similarly, so delta H equals negative 3.2 feet. What does it do? It represents a decrease of 3.2 feet in Sam's height above the ground. Okay, so that's like his whole body, not his height, right? His whole body is 3.2 feet lower, closer to the ground than it was before. Okay, so when you introduce the change in a quantity, that's a new quantity. It's different. Okay, so you've got some work to do here. When you get done with number 4, so here, this was kind of confusing in the other class. This box right here is asking you for the change in the quantity y, if y starts at negative 7.2, and the final value of the quantity is 6.89. Similarly, this empty box here is if the value starts at that quantity and ends at that quantity, this is the change from there to there. Okay, and remember that the change can take on a negative value if the quantity does what? Decreases. If it decreases, it takes on a negative value. If the quantity increases, it takes on a positive value. So after you're done with 2 through 4, then if you get through it all, then go back and work on number 1. Don't go to number 5 yet. Go back and work on number 1. And I'm going to take roll while you're working, okay? No. So, no. You're going to always write in the investigations. You write in the book. Don't rip it out. Never rip out anything. So write all your work in the book. So you have to multitask. You have to work on that with all your energy and then also be ready for your name, okay? Where's Cujo? Faisal. Ali. Nasser. Is that right, Nasser? Oh, not Nas. Not, sorry. Omar. Abdulaziz. Zachary. Adrian. Shruti. Anthony. Crystalie. Is no Crystalie? Jonathan Boardwell. Diana. Adam. Rush Jackson. How are you doing? Daniela. Christopher Calamitos. No? Jonathan Clark. Gage. Patrick. Yahira. Taylor. Jimmy. Ryan. Alex. No Alex? Michael. Fernando. Fernando. Moises. Zoe. No Zoe Barash? Sarah Benton. What's happening? What happened? Oh my gosh. No, hold on, I got screwed up. Moises. Callaway. Daniel Flores. Callaway. Myra. Mariah. Grant. Christopher. Andrew. Caitlin. Christian. McLean. Christian Kiefer. Candace. Adam K. Nicole. Dustin. Jonathan Leeson. Michaela. Karen. Lopez. Troy. Troy Marks. Austin. Austin Mathis. Penny McMillan. Scott. Not here. Angelica. Edward. Ryan. Leah Nelson. Adam Nichols. Carter. Frank. Adidas. Gabriella. Kiko. Elizabeth. Tanner. Justin. Justin Rayner. Morgan. Justin Richardson. Taylor. Farah. Brian. Lorenzo. Gershender. Oh, gee. Wesley. Eric. Goslin. Malenko. Daniel. Zachary. Wilden. Edward Williams. Lingji. Nathan. Jackie. Jackie Zong. No Jackie? Okay, if I didn't call your name, talk to me after class. If I didn't call your name, talk to me after class. Yes?
I think you called my name, but I didn't hear it.
Yeah, come after class. How do we do? Any questions on 2 through 4? So here's your chance. I'm not going to go through all these. 2 through 4. Any questions? It's the change. So this is the change in the quantity. The starting value is negative 7.2. And the final value is 60.8 nanometers. These blanks are what you're filling in. You've got 2 blanks per table. 2 blanks per table. Yeah. Delta T. Let me talk about number 2. Hold on. Talk about number 2. It's important. Okay, have everyone's attention. We're going to regroup here. Let's regroup. Okay, let's talk. What's the difference between T? So T is the number of minutes since Jesse left his house. Is that a good description of a changing quantity?
No.
Why not?
Because it doesn't tell you what changed.
Number of minutes since Jesse left his house. Perfectly good. Changing? Yeah. It can be half a minute. It can be 2 minutes since he left his house. 8 minutes. 10 minutes. Well, that's a well-defined changing quantity, and our variable is t in minutes. Okay. All right. So, what does t equals 5 mean? So, 5 minutes after he leaves his house, that value t takes on the value 5 for 1 instant. It takes on the value 5. How is that different from delta t equals 5? Anyone say no?
Because it indicates an increase by 5 minutes in the time since he left his house.
Okay. So and when does that time start, that increase in 5 minutes? When does it start?
Since he left his house.
It starts at time equals 0?
Starts at t equals 5.
It starts at time equals 5? It can start at any time. It can start at any time, and then we're talking about the next 5 minutes. That's what delta t means. It could start at t equals 3, and then we can have a change in 5 minutes. So that would be from t equals 3 to t equals 8. It could start at 20 minutes. So that delta t is an increase in 5 minutes since he left his house, starting at any time since he left the house. Where the t equals 5 is specifically 5 minutes since he left the house. Really important distinction. Okay, and any questions on any of the other ones? Okay, so 2 open web work sets. The first one's due Wednesday before class. The next one's due Friday before class. And then you have the written homework due next week. The recitation. Yeah, let me turn off the video. Hold on.